5 cards are to be dealt from a standard 52 card deck. How many such hands have only face cards? Okay, well, we have 52 cards. The larger set is 52, and we're talking about a hand of cards. Oops, sorry, this is not from 52. I was jumping to the conclusion here. If we're talking about having a hand of cards, well, a hand of cards, we're talking about a 5-card hand. When we're dealing with a hand of cards, order does not matter. Because if you're dealt an ace, 2, 3, 4, 5, versus being dealt a 2, ace, 3, 4, 5, this is essentially, say these are all of hearts. If they're all of hearts, then this, I would say, is the same hand, because you're free to arrange your hand. And so when we're talking about being dealt a hand of cards, order doesn't matter. But we need to decide what is our N and what is our R. What's the size of the larger thing and the size of the smaller thing? Well, we're only being dealt 5 cards, so I'd go ahead and say this is going to be something NCR 5. We're not being dealt from all 52 cards, though, because we're only being dealt face cards. And there's 12 face cards in the deck. So I would say this is actually 12, choose 5. 12, choose 5, which gives us 792. How many such hands have 3 aces and 2 8s? If you're talking about a full house here, this would be described as aces full of 8s. So we're talking about combinations because we know order doesn't matter. We have 3 aces. So there are 4 aces total in the deck, and we're going to be choosing 3 of them. And there are 4 8s in the deck, and we're choosing 2 of them. And I would actually, or then we want to multiply these together, because no matter which of the 3 aces we choose, there's a certain number of ways we can choose the 3 aces. Well, there's actually 4 ways we can choose the 3 aces. There are 6 different ways, 4 choose 2, different ways I could choose the 2 8s off of each of those. We're doing this branching thing with our tree. So this is why we're going to be using multiplication. So this is going to be 4 times 6, which is 24. There are just some of these smaller number combinations that I happen to have memorized, but you can get this number just as easily by doing 4 and CR2. This one I recognize as almost the entirety, so that's why I end up, n choose n minus 1 is n. So that's handy to recognize that. All right, how many such hands have exactly 2 hearts? So if you have exactly 2 hearts, well, there's 13 hearts, and we're having exactly 2 of them. But that doesn't describe the entire scenario, because if you have exactly 2 hearts, then you also have 3 non-heart cards. And if you have 3 non-heart cards, then this, like I said, is not telling the full story. We also need to talk about the non-heart cards. There are 39 non-heart cards. 3 times 13, the remaining 3 suits, or you could say that's 52 minus 13, however you want to get to that 39. So from the 39 remaining cards, you have 3. So we get 13, choose 2, times 39, choose 3. So 712, whatever, 712842. Again, that's the number I care about more, and I'd rather see this on the test than that number. How many such hands have cards of a single suit? In other words, a flush. So if you're talking about a flush, all the cards need to be of the same suit. So one way to approach this problem is to first say, we're going to branch off and say, we're going to say all the cards are of a particular suit. So we'll do all of the hearts, or all of the, I don't know, I'm not going to draw them all. I can't even think of all of them. Spades, clubs, diamonds. Diamonds are easy to draw. Whatever. You can think of 4 different ways. We could branch off 4 different ways here and say there are 4 different suits. And from those suits, if I'm in this upper part of the branch, that means I'm talking about how many hands there are that are consistent entirely of hearts. Well, there are 13 hearts, and we're choosing 5 of them. And the same thing can be said for the number of hands that have all diamonds, or the number of hands that have all clubs, or the number of hands that have all spades. Those would all be 13 choose 5. So that's why I'm okay just saying 4 times 13 choose 5. Really, I'm using the multiplication principle here. But I could have said 13 choose 5 plus 13 choose 5 plus 13 choose 5 plus 13 choose 5. So we get 4 times 13 choose 5, which gives us 51, 48.